Hello friends, this video on Atoms Part 6 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till Part 5 before going ahead with Part 6. So what is atomic spectra? What do you think can be atomic spectra? Spectra is nothing but a plural of spectrum, right? We have spoken about spectrum. What is spectrum? It is nothing but a series of different colors, somewhat like that, right? We say that when we saw that when white light was passed through a prism, we got a spectrum. What was that spectrum? It was nothing but a series of all the 7 colors which was obtained. So atomic spectra is nothing but a spectrum which is obtained from an atom. Why is it obtained? What do you do so that the atom gives rise to a spectrum? So there are many different ways by which atomic spectra is formed. So here what we are going to talk about is the different types of atomic spectra. Because why are we studying atomic spectra? First of all, because when we talk about the structure of atom, when we talked about the Rutherford's model, this atomic spectra is a very important property of atoms and it has got very useful applications in our day-to-day life. We will talk about that later. So Rutherford model could not explain this atomic spectra and it was Bohr's model which was able to explain this atomic spectra. So in order to understand what this atomic spectra is, first you should know what is atomic spectra, right? Only then you can understand what Rutherford could not explain, which Bohr could explain. Right? So we will talk about the different types of atomic spectra, that is emission spectrum, absorption spectrum and continuous spectrum. So broadly these are the 3 types of atomic spectrum which we will talk about: emission spectrum, absorption spectrum and the continuous spectrum. We will discuss about each of them in detail. Now what are spectral lines? In this slide, I am just making you familiar with the terms. What is atomic spectrum? What are spectral lines? So spectral lines are nothing but the series of bright and dark lines which constitute the spectrum. So the lines of the spectrum are known as the spectral lines. So the spectral lines look somewhat like this. This is a spectrum. This entire figure which you see here is a spectrum, and these lines which you see, the blue lines, the green, the red and the yellow lines, these lines are known as the spectral lines. And what is spectroscopy? Spectroscopy is the study of emission and absorption spectra. Spectroscopy is an extremely interesting and useful branch of science. What do we do in spectroscopy? Basically, it comes only at very higher level. You would see that scientists in big organizations, they use this different kind of spectroscopic techniques. They use something called NMR spectroscopy, some other kind of spectroscopy as well, with the help of which they try to identify substances. That means every object has a distinct spectrum of its own. Right? For example, let us suppose every human being has got a particular name of its own, but name is not unique. For example, let us take an example of any name. Let us suppose if we take the name Amit. Amit is a name, but it is not a unique name. Amit might refer to one person, it might refer to, there are hundreds of Amits, right? So it is nothing very unique to a particular individual. But for example, if I talk about fingerprint is something which is unique to an individual, right? So 2 individuals cannot have the same fingerprint. It is somewhat like that, except for very special cases, right? So similarly, the spectrum, this emission and absorption spectrum are also very unique to each particular element. So by looking at the emissions or absorption spectrum, scientists can predict which object is it, right? So this study of emission and absorption spectra is known as spectroscopy. Fine? Okay. So now let us talk about the atomic spectral emission lines. The spectrum of radiation emitted by a substance that has absorbed energy is called an emission spectrum. Right? The name itself is saying emission spectrum. That means the spectrum is emitted by a substance which has absorbed energy. As I mentioned before also, whenever we talk about a substance is nothing but it is finally made up of atoms. So this spectrum is formed because we have supplied some additional energy. So the object absorbed some energy and then it emitted the spectrum. So this spectrum is known as the emission spectrum. Atoms, molecules or ions that have absorbed radiation are said to be excited. That means when we talk about the different energy levels, we talk about the ground state. Ground state means the most stable state where the atom is completely at ease. It is relaxing. It has neither absorbed energy nor it has released energy. But now once that atom absorbs some energy, it goes to a higher energy level and we say that the atom is excited, right? So whenever an atom or molecule or ion absorbs radiation, we say that it is excited. To produce an emission spectrum, energy is supplied to a sample by heating it or irradiating it, and the wavelength of the radiation emitted as the sample gives up the absorbed energy is recorded, right? So how do we produce this emission spectrum? As I mentioned, for this we will have to supply some additional energy. Now we can apply this additional energy either by heating that object, we can give heat energy, or we can give some radiation on that object. So there are different ways by which we can supply this additional energy. Now that substance will absorb this additional energy and it will emit the emission spectrum. And then what is done? Then the spectrum which is emitted or the radiation which is emitted, the frequency of that emission is recorded, right, as a function of the energy which is absorbed. So this is how the emission spectrum is formed, right? How can we generate emission spectrum basically? So this is how we generate emission spectrum. The study of emission or absorption spectra is known as spectroscopy. I mentioned it in the previous slide as well. So this is how our emission and absorption spectrum looks like. Now we got a touch of what is atomic spectra. So now this Rutherford's model was not able to explain that why this atomic spectra forms, what gives rise to the formation of the atomic spectral lines. So it could not explain that. So what were the reasons that gave rise to the Bohr's model of atom? The first one was dual character of electromagnetic radiation. Rutherford's model could not hint anything about dual character. And the second one was the experimental results regarding atomic spectra. It also could not explain anything about the atomic spectra. So in order to cover these two areas came up the Bohr's model.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.